Okay, so once the error handling is out of our mind, let's start thinking about the state again, okay? Because right now we at least have two different set of states information. One is in the React application, and the other is in the server, with basically in the database, okay? And we need to keep them in sync through our API calls. First of all, at the application level, we should, at least in our mind, have a clear distinction between the application state or the presentation state. Okay, presentation state is all the state. They are all state or context variables in React components. Some of these variables are only used for managing of the component. Okay, so maybe the language, or maybe the text that has been typed in this moment, or maybe an error message that is displayed, or something like that, or maybe the sorting order of a table that the user selected, and something like that. Okay, this state is normally only living in the client. Is not stored anywhere else, and in many cases it's also transient, so after a while you don't need to remember it. It's just a state for a short-lived amount of time, and that doesn't create any problem. It's just client only. Okay, the other state, the application state, usually is a local copy. You can think, I think about as a local copy in the React application, in the client, of some information that is really in the server. So in a client-server application, the truth is the server. The real truth is only data which is stored into the database. Everything else are just temporary copies. Okay? What we have an API call result is just a copy, snapshot for that query in that moment. We transfer that into a React component, into a use state. Okay, that state of a component is a copy of some information that we had in the server that was valid at the moment in which it was read. Okay? When we read something, we are reading a copy at a given point in time. If the truth, so the server, changes, the client is not updated automatically. We should maybe refresh or check again if. So I have a list of questions, it's displayed on this page. If another user comes and adds another question, my page doesn't display the new question until, for some reason, I decide to refresh my information. Okay, this is the curse of client-server application. All communication is always started by the client. The server has no way in HTTP to say, okay, look, I have some new information for you. We should use, if you need some real-time, say, information from the server to the client, we should use other protocols like WebSockets, for example. In HTTP, it's not possible to have this kind of two-way real-time communication unless the client is polling periodically the server, asking, is there anything new for me? For maybe, are there new questions, are there new answers, and so on. Okay? So, but this is something that we should manage explicitly. So the problem is keeping the copy of the state, which is in the client, in sync with the server. And these two copies may become out of sync for two reasons. One, because the server modified, or some other users modified some information in the server. So the information that I'm currently displaying is stale, it's no longer updated. It's an old copy. And it may be a problem if the user makes some decision based on the information that is there. Stupid example. I have, after a question is posted, I only have 1 hour to post an answer. Then it's closed, for example. Okay, so a question has a flag open or closed attached to it. I'm reading the question, and I see the question as open, so I have the form for replying, for example. Then, for some reason, the question becomes closed. or after a timeout, or maybe because the user deleted the question, or maybe it reached a given number of answers. There are maybe many policies for which this question is now closed. But in my browser, I still have the question and the form for replying, because my browser doesn't know that in the meantime the question on the database has been closed. So the problem is that my application could maybe send a post saying, okay, I added a new post to this question, and the post will be rejected. And will be a surprise for the user, because the user sees a perfectly valid response, but the server knows that this question doesn't accept any new response. And it's a problem, because the client is lying to the user. He's telling the user that something could be done, while it was possible some time ago, but now it's not possible anymore. Okay? This is a problem when we have multiple users on an application, and there are some dependencies among the different the operation done by the different users. This is something that we'll analyze. We try to mitigate this effect, but it cannot be really solved until we have some, say, aggressive polling or refreshing mechanism, or you are using some extra protocol for keeping this. So this is one possibility. No? The server data changes, the client doesn't know it, and so it displays all the data, and it allows the users, or it promises to allow the users some actions that may no longer be valid. Second possibility is the other way around. Okay, the client changes some information. The stupid example is the vote button. I click in the vote button. So in that moment, I have one information in the client that the server doesn't know yet. So for this vote to be really acquired, the truth should be transferred to the server. Okay? So until the number in the server database is increased, that vote is not really counted. This could take time. Okay? In this meantime, the client knows that we have an extra vote. The server doesn't know about it yet. So there's the issue of how to be sure that the vote is counted in the server first, and the issue of what to display to the user in the meantime. Because it could take some time for the vote to a server, and to have the confirmation from the server that this vote is still counted, because maybe it's no longer valid, or we saturated, or the question has been deleted. There may be many reasons. Okay? We have these two states to keep in sync, and we need to do extra work for that. And okay, these are just okay. In React, there's a very strange terminology for talking about this state information transfer from the client to the servers and vice versa. And they're talking about hydrating a component. Okay, so like you're watering some plant and you're giving the information on it. So imagine that a component is dry, it doesn't have any information, and then you hydrate a component by putting data into it. Okay, so hydrating or rehydrating means in the jargon of React, loading information from the server to the component. What we do in our initial useEffect, load question, load answers, give me the information. I have a component that doesn't know what to do, and then I hydrate this component by doing some fetch at the beginning. Okay, hydrating should normally happens at the beginning of the component, but may also happen more times. The component may decide to refresh itself. When? Once a second, once a week, when the user clicks on something, according to some other user action, we decide. Okay, we know that every time we could call the load answers and update the state, the local state. Maybe the new values are identical to the previous one because nothing happened on the server, or maybe the new ones are updated. Maybe there's changed scores, changed questions, and so on. So we have a first hydration of the component, loading the data, and maybe we have some rehydrations driven by some refresh mechanism if we need to put it in place. Okay, of course. But the truth is that the React app application doesn't know, and it's impossible to know when a refresh is required. A refresh will be required if the data is the current data needed for this component has changed in the server. But there's no way to know until you ask. That's the nature of client-server protocols. And so we can only approximate this rate rating if we are using HTTP as a protocol. Okay? The reverse is called dehydrating, very stupid but term, in my opinion, means that some information which is in the component is then stored in the server. Okay, so it happens whenever the user or the application needs to store something. So whenever we submit something, we click on the button, then the server will store it. So in this case, from the client point of view, it's easy because the client knows that it has something hot to tell to the server. Okay, just imagine that when I click on the vote and the connection drops, the risk is that I'm losing this information, I'm losing this vote. Okay, so the client has something hot in their hands and is trying to push it to the server as soon as possible. But it is all in control of the client. So this is easier. We know when we have fresh data in rehydrating in story, in dehydrating in story. Hydrating mount time is easy, is what we did. We should only be careful about two issues. One is the empty state, and the other is the delay. So we saw it, remember, when we tried to... Why don't you show any answer? I should have messed too much with the code, probably. Okay, but we saw this already last time when we jumped directly to a route that wasn't the home route. Okay, and we had this error: queue is undefined. Okay, and why? Because all components are rendered once at the beginning with the default value for their states. Then the useEffect triggers, and then the state is updated. Okay, so in this case we have this question component that renders at least once with this parameter is there, but props.question the first time is equal to the default value of questions from its father component that is empty. So the first render of a component is always with the default value of the state. The default value of the state of all state variables for each component. And also, this state variable will propagate to the child components. So we should ensure that the first render happens without errors. This error is strange because we know that this question list will be loaded soon, very soon, in 50 milliseconds. But it's not being loaded because the application crashed. The application crashed because in the first render, when the list of questions was still empty, I was trying to access the first element. Crash. So we should always ensure, you see, Q is undefined in our code. Q is our local variable. So the component list of questions that we have in app here what's wrong here? You were working a second ago. Course. I have something wrong. Sorry, I have a bug here in server line 49. Sorry, I have a bug from before. Okay, the error is header sent. It means that I already started setting some response body, and then after that I try to add a new header. Okay, so probably the JSON. So what it's saying is that the status 500 can only be applied if the body has not been sent yet, because headers are before the body. If I start to write the first line of the body on the response, okay, the Express needs first to dump all the headers and then the body, and then the first line of the body. After that, you cannot change the headers anymore. Okay, so what it's saying here is that probably here, if it's an error, I return here status. Yeah, I should return there. Okay, otherwise return here. So I don't see why. Sorry. Okay, 4921 is this one, of course. So this status.json, it looks like yeah. No, 49 means we are in the exception handling, right? 49, if we are here, it could be the exception coming from list answer of. Yeah, probably it's this one. When I write JSON or end, I'm closing the call, okay? So I'm sending the response. In my mind, it was a return statement, but in JavaScript, it's not a return statement. The execution still continues. I'm just scheduling the answer. So the code, even if I wrote this error, the code goes through and try to call list answer off, which will fail, and the exception will be called there. But at that point, I already sent the body there, probably. Okay, my hypothesis. Let's see. Yeah, it was that. So when I call JSON and end, I should ensure that no further instructions are executed. It doesn't interrupt, like a throw that interrupt or return that interrupts the function. The function will still go on, and in this case, it did something wrong, of course. So, as always, my problem. Okay, like I said, this component is not affected by the loading problem, this list, because we don't see it, but for a little while, the component renders with an empty list, and then the list is replaced with the actual list of 2 questions. Now we have at least 2 renders here. Okay. So at the second render, everything goes okay. The issue is that at the first render, so here we are at least after the first render. So we already have this information. The problem was when we were loading here, and the first render didn't go through. So the warning is, let's try also always to ensure that even with the default state of all states variables, we are rendering something meaningful. We don't crash the application. Maybe we don't render anything. Maybe we keep it empty. We know that in a little while data will arrive and then we will have a good render. For example, in our component, the question component, we have this queue, and we can render all of this only if queue is defined, maybe. Okay, so queue, and we just put a guard there. Say okay. Yeah, you need a component, so you must first wrap into a component. Something like this should solve the issue. Because at the first render, we realize that the data is not ready yet. We don't try to render anything. Immediately after, the useEffect in-app will receive the data. It will change its state. The state will propagate it to my props. My component will re-render with the new props, where now I have the list of answers. Actually, the new list of props would be, yeah, this is a single question. The QID is already there, but props.question in the second or third render, depending on how many steps it takes, React takes to do that, to all this propagation. In the second or third step, props.question now contains an array. So this filter works, and this queue becomes true, and lets us render the component, and so on. Okay, so we should be careful about this detail. We already have in mind that we are rendering some data, but at the first, even if the data is there, the first render is always dry, empty. And so we just let the application have a little time for getting the data for the next render cycle. So this was the first. While the component is empty, it should render something meaningful. Maybe an empty page, but not crashing. The other issue is the loading time. Okay, so loading is easy, because imagine that, let's go back to app, so the first thing we do. Okay, until this set question is called and is executed, we don't have anything to show to the user. Nothing. If this call returns in 10 milliseconds, it's not an issue. But we never know about the server load, we never know about the network, and so on. So imagine that this actual load question is taking a long time. What should we do? Well, the idea is that we have, so what the application already does is to display an empty state. It will display a list with no element inside. If we want, we can fake it. No? In server, if we add, where are we? In the get questions. Yeah, this one. We could try to delay this response. Okay, let's imagine that we put a delay of an extra delay of 1 second or 2 seconds here. We put this into a timer, and then we respond later on and see what happens. Okay, what happens at the client level. So let's damage this and say, okay, set timer, timeout, by running this code. Yes, but only after 2 seconds. Okay? So what happens if I load the application from the home page? I have an empty page, and then later on the questions start appearing. Okay? And the same if I jump in an internal page. Sorry, in this case, Because in this case, it's not only the list of questions, but only a single question. Okay, sorry. So in this meantime, it's a long time, the user is noticing that. What we could show is a sort of message or animation or something saying that the loading has started but not yet completed. So we are going from one state, one condition in which the state is empty, to another condition in which the state is loaded. In the meantime, the state is loading. The difference is that we already started the load operation, and so we could provide the user some feedback that this is happening. Okay? And not leave the user with an empty page. So this is a common pattern when we have something to load, like this list of questions, that will update. Sorry, I got into the app. When I have something to load, like this list of questions, in many cases we are also a sort of a twin local state that is remembering the state of the operation. Is it loading or not? Or already loaded? So the idea could be, again, the other questions. We have a loading state that initially you state maybe false. Okay, initially is not loading. Then, once the useEffect for rehydration is called, before starting the load questions, I set loading to true. And finally, when the load question completed, so I have done or scheduled a set questions, I will set loading to false. So I imagine a Boolean variable that is telling me whether there's some load operation still in progress. Right now, I only have one load operation, so I only need one Boolean variable. If I had many useEffects in the same page, each one should be governed by its own variables that to keep track of which is loading yet. And now, again, this loading state, true or false, can be used to affect the rendering. So maybe we have the, again, we'll go to the render. Okay, we had this error messaging. We could have if loading. We can write page loading or animation or something, and then we proceed with the rest of the page only if, for example, is there no error and is not loading, for example. This is a very crude. Usually, I should probably at least render the header. The application put loading only on the part of the page that shows the question or a spinner, but then it becomes a layout issue. So the idea is here, if I rerun it, it's tell me, wait, the page is loading, and then it will appear all at once. And we tend to have, every time we expect some operation to be slow, we use this kind of pattern. So again, when thinking about the render of the application, we have the normal state in which we are designing the content, the real content. We have an empty state that is probably shown only for a very short amount of time. And then we have the loading state. I mean the short amount of time because there always be a first render. I'll go to the use states above. there would always be a first render with the question empty and loading false. Then immediately after, I'm setting loading to true, and I'm starting to load. So I have the question still empty, but loading true, and so I can manage it. It doesn't wait for anything external, so it will be done immediately. But the first render will always be with the default state. And then finally, we have the final case in which we have all the data loaded, and so the application can work at its best. The good part is that React guarantees that all, let's say, state updates, you know, they are not synchronous. They are scheduled asynchronously. But React will complete all state updates before the next render. Because these two calls are two asynchronous calls, actually, as scheduling state updates. We don't know in which order they will be executed, but we know that they will both be executed before the next render. So there's no case in which we are rendering something where the data is updated and loading not yet, or vice versa. It's not true in general for a synchronous function, but since in React we have this cycle render, commit, it first completes the commit cycle, so all the new state variables, and then start a new render cycle. So every time we have more than one set state in the same run, they will be queued and they will be executed before the next render cycle. This is a guarantee, no, that is at least one problem we don't have to care about. We know that the state updates are not synchronous, but are executed before the rendering, the next render, actually. Okay, so this issue about delays in just hydrating is just a matter of telling the user that something is ongoing. It becomes a bit more complex when dehydrating, as we are going to see now. Okay, so actually the slow responses are normally, you see that we have some state and then a waiting or pending state to go with it, and we have just, we set into true and then to false, and then in the case of waiting or pending, we have to display something different. And so it's boring, but not difficult. You remember when we were ending forms that we say that we have two options. One is to have the control forms, and the other the uncontrolled form with the useActionState hook. Okay. We still didn't modify that part of the code, but in this version, if I'm not wrong, I have the answer form that was managed with the uncontrolled method. Yes, it's the uncontrolled form, and we were using the what is that? Yeah, useActionState hook. And at the time when we learned the forms, we still didn't know about fetch, but we had the useActionState returns three different values. One is the form action, this is the callback which is used. The state, the current state of the form that is updated, so from the old state to the new state. And then there was an extra variable, is pending, returned by the hook. Actually, if we are using this hook, the pending state is automatically managed by that. So what the hook useActionState is doing, it will set pending to true as soon as we click on the submit button, and it will set it to false as soon as the action function has been returned. So right now, our form action was a very here was a synchronous function. So, but you could imagine that when you are running this function, the submission function, pending is true. After this function returns, pending becomes false again. And it's managed automatically by the useAction form. Okay? So we don't need to set and reset these variables ourselves. In this case, it will not do anything, in this case where the add answer is still synchronous, is modifying the state, it will always be false. It will never be pending because we are never waiting for something external. It's just synchronous code. But as soon as we are calling an external API with answers, there will be a time interval in which the form reports that the operation is pending. And then, again, it's up to us on how to use this information in the render of the form. For example, one example would be of disabling the buttons of the form, or disabling the fields, so that while the operation I submit, I click on saved, while the save is in progress, I don't let the user modify the data or something like that. And then after it's completed, maybe the page changes or we navigate somewhere else. But for the moment, the pending state can tell the user that something is in progress, but it's still not completed. And we are still not sure it will be completed successfully. So we cannot just imagine when the user clicks on save or add, we cannot just go away, navigate away to another page. Because maybe this add or save doesn't succeed for network problems, for any other reason. And so in the case of errors, we should keep the user on this page with the data he just entered. So I complete a very long form, I click on save, and it brings me to a new page that tells me error. And I need to start from scratch. No, it's not a good experience. So I am on this page, I fill the form, I click on save. The form stays in a disabled state for a while, and then if the operation is successful, it brings me away to another page. If the operation had some troubles, I'm still in that page, and I will have some error message, and I have the chance, the opportunity of updating, of changing my data, or correcting my errors. So that's why also when we are saving some data, the pending state is important. We are pending until the data is saved on the server, so we are sure it's safe, safely stored, and we have the confirmation that it has been stored. So we have the response. So that's the other part, the complexity in dehydrating. User action state just helps us by managing automatically this pending state or loading state. It is called loading. Okay, what other problems do we have? Well, the most complex problem is that a server can be visited by many clients at the same time. And as we say, the truth is in the server, but the client only have an approximation of this truth, a copy of the truth at the time they last checked. Whenever one of the other clients saves something, stores some data, votes something, and this operation, this add or edit or vote operation is stored in the server, immediately all the other browsers have stale data, old data. Because data has been changed by one of the clients, but the others don't know it. That's a problem that cannot be solved in general. And in particular, in this course, we are not learning how to solve it, because it requires managing different protocols. What we should be aware is that when we are saving some data, when we are storing something, we are never sure that the data that we have is the latest version. For example, if I have one answer, I want to vote on that answer has 5 votes. I click on vote. I can never be sure that this vote will be number 6. I don't know. So the client shouldn't make any assumptions about it. Shouldn't tell the server, now the votes are 6. because maybe somebody else already voted 3 times, so now the value is 8, and so with my vote will become 9. Okay? So when we're talking to the server, we should always only say what is happening, what we are contributing, but never assuming what would be the final result, because only the server knows. I saw many cases in past exams, client application increasing some number which is stored in the server. And this is a bad error. Like, for example, I am creating a new answer or new question. Or the client is creating the ID of the new question. No. By taking the last ID plus 1. The client cannot do that, because the client knows the last ID of the question that he saw some time ago, but he cannot know whether in the meantime some new question appeared. So that may not be the real last ID. It was the last ID some time ago, but maybe something happened in the meantime. So in this case, the sequential number, the last ID, should always be set by the server. We already did that in our example, okay? But when thinking about your project, your exercises, always assume that the data that you have is stale. Some data may have been changed, some data may have been deleted, some data may have been added. So when planning about the interface with the server, never send some data for which the server may have a different value. Because you are risking of overwriting all data, which is the problem that we have in concurrent programming, by the way. Okay, you have a variable, you cannot, you should increase or you can change a variable only in protected section where you are sure that you're the only one. Here we cannot have a protected section in a distributed system. We have one centralized point, which is the database. So in the database, data is protected. Okay, so the increase of a value should always be in a database, not even in the server. When we did the vote, let's go back to this. When we implemented the vote in the server, where is that? Okay, we called an API, where is that? Vote, not empty, this is a validation, async, validation result, there is down, okay. Vote answer. Vote answer, and then we see that the vote is increased here, inside the query, okay? It would be an error to make a query for the current score, increase by 1, and then make an update with the updated value. Even here, if I break this into 2 queries, one for reading the current score and one for updating it and increasing it in the meantime, it's a problem, because we never know if another user is voting at the same time. Okay, and so we may have 2 different users voting on a score which is currently 5. So the first user is triggering an API saying, okay, upvote answer ID number 5, 100. 5 is the score. And so I have read the score 5, increase it 6, store it in the database, update 6. But if at the same time somebody else is coming, we don't know the interleaving of the 2 queries. We have 2 queries, read the name, select, update. And the other also does select and update. And since they are asynchronous, it may happen that they are executed in different times. So I'm updating the first score, 5 to 6, and then the second one will read 6 and update it to 7. Or they may be intermixed, like this. And so both are reading 5, both are computing 6, and both are storing 6. So from 2 votes, I only counted 1. it's written one line after the other, but it's all asynchronous. Okay? So when updating something, always do that in a place where, in atomic operation, as much as possible. The database guarantees that. The API server doesn't guarantee it. We know that, you may say, what? But you told us that JavaScript is single-threaded, okay? So if I'm processing this post, then the Express cannot be accepting a process in another post. This would be true if inside the body we wouldn't do any asynchronous operation, if we replied synchronously. But since we are doing some queries, the execution of this post will be suspended at some time. And so other posts could be called at the same time. Okay, so single-threaded doesn't mean that start from beginning to end. It executes from beginning to end only if we have no asynchronous operation in the middle. But since we have, there's no guarantee that the function is the execution of a function with asynchronous behavior is not atomic. That's the shortest sentence that I can say. Okay? So always be skeptical about your data and the data that you have. This is just maybe a minor point, but can create big bugs in the code. But that works until you don't have many users, and when you start having more than one user, then everything crashes because you start having duplicate IDs, you can start having lost data because somebody is overwriting somebody else's data, because they just assumed that the slot was empty, that this number was not used, and so on. And it's the case where, okay, if you are testing with yourself, everything works. When you put in production, everything breaks. So one of the many reasons. I think it helps thinking that the client state is always an old copy. Treat it in this way. The only thing that you have is the only place, the only moment in which the client has some data which is newer than the server is data typed by the user. It's the only case. In all the other cases, the data in the client should never be used to make the call to make an API call to the server. The server already knows better. Okay, so that was one issue that we cannot solve in HTTP. We cannot solve in general, because it's the general problem of distributed synchronization. It's an unsolved problem, unsolvable problem from a theoretical point of view. We could have some solutions that might be using WebSockets or other protocols, or publish and subscribe solution that can help us manage the problem easier, in an easier way. So getting the fresh data sooner, and especially with some server action. Because if you have 100 clients which are constantly polling our server, saying, okay, is there anything new, is there anything new, is there anything new, the load on server would be just wasted, okay, because the server will just spend time replying, no, there's nothing new. So what should we do? The resolution should be using some protocol that are made for asynchronous, for bidirectional synchronization. So the client could be informed as soon as some new data or changed data appears. In our case, we should just say, okay, let's try to refresh the data frequently. Maybe we just use some extra loading operations, and so, for example, if I go to the network panel, you see that we are calling, even our normal behavior, we are calling the same APIs many times. And in this case, we are sort of relying on the caching of Express. So when we are coming back to the home page, maybe the questions are being reloaded, but they're already in the cache. If the result of the query would be different, then this express would give us the full new answer. If it's the same, the React will tell us that, okay, you already have it in cache. You see that all this 304 is already not modified. Okay, the response to this query will be the same as before. So I'm not providing you anymore. So we are making some extra calls just in case something changed. And the check will be done by the server, by Express. We do that, that's the query, check the JSON and say, okay, this JSON is identical to the previous one. I'm not giving it to you. So we are not afraid of doing more, say, data loadings than is strictly needed, because maybe some data has been refreshed in the meantime. It's not a real solution, okay? It's just something that, okay, when we navigate out and we come to the same page, maybe data has changed. So all navigation actions are in a way refreshing data, if we want. In other cases, we should maybe set some interval timer where every second or so we reload the data, we refresh it, especially if you're doing some like multiplayer games or something like that. Of course, we are not, with these techniques, we cannot do real-time multiplayer applications. A chat could not be done here, unless we are doing a very, very strict polling by hammering the server with many calls. It will require other type of protocols, or other solutions for faking bidirectional protocols. For example, one solution is the so-called long polling. So actually, so the solution based on polling means I'm asking for the server the same data over and over again. Or I'm just asking to the server, did the data change or not? So it could be just a simple response, yes or no, but I need to ask to the server. The long polling method is making a fetch to the server, an HTTP request, and the server does not respond. If there is no new data, the server does not respond. It lets this call timeout, 30 seconds or something like that. But if some data is changed, the server actually responds. So I always have one HTTP request which is still pending. And that could be a channel by which the server is able to send some data to the client as soon as the data is available. It's complex to manage, but it's also a solution that works on HTTP to anticipate some data. You poll once every 30 seconds, but the response comes as soon as it's available. There are, of course, don't do it by hand. There are libraries for doing that if you need. But there are all different ways of working around the client-server problem. Another problem is with useEffect itself, so it doesn't concern the server, about the dependency arrays, actually. And it's easy, if we are not careful, to create infinite loops. And they are not very intuitive, so let me show you some examples. So here we have, what do we have? An effect that is increasing a counter. So we have some data, and we have a handle change that will, so it's an input with a control form, okay, value on change, and the value setting the new value, okay. And the counter counts the number of times the user changed something. So in our idea, every time the user types something, it triggers a change, and this change increases the counter. Why? Because we don't have any dependency here, so it will be called at every update. The user types something into the box, handle change is called set value, the value is changed, the component is re-rendered. We don't have a dependency array, so at every re-render, the effect is executed. So it should actually count the number of refreshes. Actually, it doesn't, and it enters an infinite loop. Why? Because after the setCount is called, C is changed. C is a state. Okay, sorry, count is changed. Count is a state, and so if count goes from 0 to 1, I schedule a re-render of the component. Scheduling a re-render causes the effect to run a second time. So the component is rendering whenever value changes, right? And also whenever count changes. So see, count changes, I call the effect. And this will cause count to increase again. And so I will re-render the component again. This number will continue to increase in an infinite loop. The reason is that here we don't for making this work, we should have a dependency array with value inside. So let's run this effect only when value changes. If count changes, we don't want to run the effect. If you have, and this is the same as we had C in the dependency array. Always be careful when you are in an effect, we are changing a variable which is in the dependency array. Because then you are changing something that will trigger a state change, that will trigger the execution of the event, and so on in an infinite loop. There must be cases in which the execution of an effect doesn't change any state, so that on any state on which the same effect depends. Okay? Otherwise, no, we are triggering the infinite loop. In fact, here the solution is let's be explicit about which states are allowed to trigger the update. Another corner case, we have an effect where a state is composite. Say we have a secret value with a count of the number of times this secret has been changed, for example. No? The password has been changed 5 times. So here it's okay because we have again a value here. It's a control form. The user can change. The dependency is correct or secret. Okay, so we are not in the case as before. So only when the secret changes, then the effect is executed, and if the correct value is found, then we increase the number of counts and so on. Okay, so the issue here is that the dependency variable is an object. It's not a value. Okay, it's an object. It's a state object here. And at every execution of the function, the variable pointing to this object will be new. At every execution of the function, the variable secret is different and is pointing to the same state. So we are creating a new object at every execution. So the value is the same, but the object itself is different. So in this case, having an object as a dependency will always change at every run, will always be considered as changing at every run. So the solution is don't use objects in dependencies, because they will always be true, they will always be changed. The reference to the object will change even if the value, of course, for efficiency reasons, React cannot go and check, do a deep comparison with all the attributes of the object. Just compare the objects themselves. In a different one, no, the object is destroyed and is recreated, so it will be a different one. With the same values, maybe. So don't put objects as dependencies, because otherwise they behave like they were always changed. This is for objects, and is the same for arrays. Okay, if you have a list of items you want to increase and so on, don't have an effect that depends on the array itself. Okay, because again, array is an object, so it behaves in the same way. So that's, remember a couple of times ago I made an example of adding something into the array. In the dependency I put array.length, not the array itself, but some length or some value computed out of the array. A value always, a number or a string. And since they are primitive values, they will be compared by value. Otherwise, if we are using objects or expression that leads to objects, they will be compared by reference, and they will be always they will always be different. Okay, so this is very inconvenient in my mind, because it would be very nice to have an array or a list having the comparison, but it doesn't work. Okay, so the dependency array is something that should contain, let's make it simple, primitive values, booleans, strings, numbers. It's not the only possibility, but to be safe, we can do that. And finally, the problems about dehydrating or saving data. Okay, basically posts. So here we are putting together all the issues that we had until now. In a post, you see that I'm not into a useEffect. This is a normal callback. On click, execute this code. There's no effects involved, just code, just an asynchronous callback. That does a fetch. Okay. The issue is when the user clicks on the button, the client knows that the data is new. The server doesn't know it yet until the post succeeded. So we can be optimistic or pessimistic in handling this. The client has newer data than the server. So should the client already show the new data to the user? Maybe so, maybe yes. Or should the client wait until the server stored the data safely and only then show the new result? It's a choice. Okay, it's a design choice. One possibility could be like we did here. In parallel, we are doing two things in parallel. One is to take the new item element and already add it to the local list. So we already have a local state, okay, for the list of questions, list of answers, or whatever. We can add the new item to the list locally in the client, and so it will immediately show in the page. And in parallel, we are saving this data to the server. Optimistic update. I expect this update to be saved correctly, and so I show it in 0 time. The interface already shows some data which is not stored in the server yet. It will be in a moment, hopefully. Then what I would do is after this fetch, I would probably do a refresh of the state. So I change the state locally, I save it to the server, and when the call to the server, the post is completed, I will do a load of the state just to refresh the data from the server. That I should receive the same data that I just added, plus my other variation. But no, then, so I'm sure. If something goes wrong, then the new data will appear, I send it to the server, error, or for some reason the data is not saved, and so when I'm refreshing, the data that I added optimistically will just disappear. Not nice, huh? Okay. The alternative is to wait until the server tells me okay. So the user clicks on save, I start in the post. When the post is completed, all the error checking is done, at that point I will update the list. I can update the list with the element that I just added, or I could refresh the whole list from the server. This is safer. Of course, it's slower. The the saving of the data always takes the same time. It's slower in displaying the result to the user. So we either show the user loading states, and okay, this is being saved, wait a second, or we start displaying the new data, and then we be ready to change it. Okay? So in this case, we don't have any parallel updates. We have this, let's say, weight, extra weight. We can combine the two together. The best solution is complex, so maybe we don't want to do it for everything. But the idea could be, okay, let's think we are adding an element to a list. When the user clicks on add, we are adding it locally, but maybe we are marking it in some way, with a gray background or something like that, with an icon, say, okay, this is still temporary. In parallel, we'll update in the server. When the server responds, we are refreshing the full list, and so the data will become valid. So actually, this means practically that our local state will have an extra attribute for every data, which is pending yes or not. And when rendering the list, if it's pending, we show it in maybe in grayed out color, saying, okay, this is the data you saved. The user will see the data already appear in a semi-visible state, and then after a while, it will see the data in a solid state when the answer from the server comes. So these are quite easy to have a progressive showing of the user that we are saving the data, now it's saved. And if it disappears, then we already understood that there's not a solid data being disappeared, but it was temporary, so it can be expected. And so, for example, here it was a very, very simple way of saying, okay, when we add the new item locally in an optimistical way, we are marking it in some way. And then when we are going to refresh it, you see a get items call here. We are refreshing from the server. Of course, we are replacing the temporary element with the final one that will be displayed as well. So even here we have a state where the item has not been added yet, a state in which it will be added to the client only, and the operation is pending, and the state in which it has been added also to the server, and finally a state in which it has been added to the server and being reloaded by the client again. Only at that point we are sure that all data is synchronized. And in the meantime, we are showing some intermediate state that could be empty, it could be a loading, or can be some predictive state, predictive data to the client. If we want to do it the right way with all the intermediate states and so on, it's demanding. So you need a lot of special cases. So in many cases, we don't need to do that, especially if in our case the server is local. But it's important also to think about where is the latest version of the data. I think this can be, in our case, in our application, this only applies to the upvote and to the edit or save of the form. So that could be something that we can modify. I will, after today, I will try to implement this kind of logic into these two functions, and we'll upload that after a couple of days to the repository so that you can have a look at one possible implementation over the lines of this example. This is the safer case. It's the more complex because you have to handle 3 cases, but then you are robust. You don't risk of showing invalid data or vice versa. And then for each case, of course, you need to evaluate how much to make it complex. Okay, always start simple. I'm thinking about the exam. Start with something simple, complete the functionality you need, and then start thinking about corner cases that are many. Okay. Okay. So I think that's all for today. And next week we jump into authentication, which is again very complex, but we will follow a library that will actually tell us which steps to take. Thank you.